Well done, guys.
Let's do some exponents. Alrighty. So what I've put here for you guys is essentially everything that you have done so far. Actually, maybe let me rephrase that. The bottom 4 blocks are everything that you should know so far. What we're going to do today is this first definition of exponents, which is the power of 0. Now, the reason it's a definition is because it comes from one of our laws. It's not a law by itself. We get this definition by applying one of our laws. And so it's not a whole new thing that we sort of have come up with. It's just an extension of one of our laws. So if you want, maybe take a screenshot of this page that you've got all of your laws together and in this first definition. But I'm going to explain the definition 1 or the power of 0 rule that we use in exponents now. So if you want to wait to take a screenshot so you've got the explanation, that's also cool. Alrighty, so let's have a look at this whole 0 exponent thing. This idea of a 0 exponent comes from our second law, so our law of division. Now, the reason for that is because if we look at our law of division, and let's say, for example, we've got x to the power 5 divided by x to the power 3. We know that this law tells us that we subtract our exponents. So we take the numerator minus the denominator's exponent, and we get our simplified answer. Nice and easy, nothing stressful there. We know this. We've done this. We've practiced this. We're sorted. But what happens when we start to divide a value by itself? So what I mean by that is, what if I'd given you x to the power 5 divided by x to the power 5? Right, now, according to my second law, all I need to do is subtract the exponents. So 5 minus 5, and that gives me x to the power 0. But the question is, what does that mean? So let's think about this for a second. If I have any value, I'm down here by the red star. If I have any value and I divide it by itself, so 5 divided by 5, 10 divided by 10, I don't know, negative 100, oh, golly, smolly, right, we got there. Negative 123 divided by negative 123. Anytime I divide a value by itself, I get an answer of 1. And so here, when we've got x to the power 5 divided by x to the power 5, I'm dividing a value by itself. And so what that means is I'm getting an answer of 1. And so this x to the power of 0 actually means 1. And this is why our first definition says, any value, any non-zero value that we raise to the power of 0 actually has an answer of 1. So if you are going to do the subtraction, you do need to write the exponent of 0, but that is not your final answer. Your final answer is then 1, because we want to simplify it even further. All right, so what we need to remember is that whenever we see that power of 0, we should be thinking, or our head should be telling us, we potentially have a 1 that we need to work with. So I'm going to stop here in case you want to take a screenshot. Just that you've got all of the explanation and so on there for you if you want it. And then we're going to put this into practice. So, Pampuru, I hope I answered your question in terms of, do we have to put the 0 there? But if not, obviously, do feel free to either raise your hand or put it in the chat and we'll help you. For your question, there should be a pop-up to unmute yourself. Okay, so I see Voi's question coming there on the chat. So the power of 0 is basically us dividing a value by itself. So for example, if we take the exact definition that we have there, this is essentially saying x to the power a divided by x to the power a. whenever you divide something by itself, you get 1. And so if you now apply the second law of exponents, which says subtract the exponents, a minus a is 0. So x to the power of 0 is the same thing as 1, because you are dividing a value by itself. And whenever we divide a value by itself, we get answers of 1. It doesn't matter what that value is. Anything divided by itself is 1. And so that's why we have this 0 exponent. Okay, I hope that makes a bit more sense. I'm hoping we've all got our screenshots. We're going to have a look at some examples now and put this into practice. Alrighty. Oh gosh. So let's have a look to start off with at example, very excessively big. Example 1. Before I do that, Ivana, I see your hand. Question?
Ma'am, I was going to ask, so ma'am, if you go back to where you were doing the examples, so you said negative 125 divided by negative 125. Are you allowed to put two signs next to each other?
You can, because these operations, how do I word this? These operations sort of have different levels to them. Division is much more important. It probably is more mathematically correct for me to put a bracket around though.
Okay. Thank you, ma'am.
Probably better. Spiwe? You there? There we go. Oh no. Spiwe, can you hear us? Okay, it seems like not. It's not the end of the world. Let's try again. Oh no, we can't.
Good evening, ma'am. To answer it.
Okay, so give a try for me. What do I do?
You say x to power 2 times 0.
Okay, and that gives you? Okay, so people, we seem to be struggling with some sound here, but you're on a really nice track, and I know that you've probably gotten it right, so don't stress. We're going to finish it off. So exactly as the people said, guys, we distribute 2 times 0. We know anything times 0 is 0. And because we know that we now have this x to the power of 0, we have an answer of 1. Now, you don't have to do the distribution. If you see automatically that you have got a base raised to an exponent of 0 and you know that is 1, you're welcome to go straight to the answer. But understand that there are different ways to do it. And if you're more comfortable doing the distribution first and then getting your answer of 0, that's cool. There's nothing wrong with that. Alrighty. So take your screenshot of this one if you would like to. And then we're going to have a look at question B that you want to say you're going to try by yourself. Let's just see what it is first. It's a fun, exciting game. I do my own prep, but I never remember what I've done. Okay. Yes, you're going to try this by yourself. Give it a go. We've got open bracket 2x cubed y squared, close bracket to the power of 0. Think carefully. Remember, if you need to distribute, distribute. You're welcome to put answers on the chat. We like to see the answers that you're getting as you go along. Spirit, don't stress. I completely understand that network is giving all of us a bit of a run around at the moment. So don't stress. You're on a really nice track and we finished it off. And I know you got it correct. So well done. Okay, and so I was saying, do you want to help me with B here?
Yes, ma'am.
Okay, tell me.
So what I did was I first said that the 0 outside the brackets times with the 1 in front of the 2. So like the exponent, which is 1 in front of the 2, 1 times 0, which gave me 0. So I said 2 to the power of 0. Then I said x. Then I said x to the power of 3 times 0, which gave me 0. So I said x to the power of 0. Then I said y to the power of 2 times 0, which gave me 0. So then I times them all together, which gave me 1.
Excellent. Well done. So guys, because all of these are to the power of 0, they actually all have a value of 1. And so because it's all multiplication, 1 times 1 times 1 is 1. Now again, if you're happy that you see that you've got a base, so the whole bracket to the power of 0, and you're happy to go straight to 1, go for it. There's no stopping you. But that distribution step is more than acceptable, and it does actually help us see which values are going to become 1 and potentially which values are not. So it is quite a useful step to keep doing for yourself to make sure that you're getting the correct answer. Very nicely done, Tabasane. Right, I'm hoping we've taken screenshots if we need. If anyone has questions, please remember to raise your hand or pop them in the chat. I know exponents can sometimes be quite intimidating, so let's just make sure we're all happy and we're all comfortable with what we're doing. Alrighty. So what I want you guys to try for me are these 4, C, D, E, and F. Think carefully about where that 0 exponent is sitting. Think carefully about which values are being affected by the 0 exponent. And then you're welcome to put answers in the chat. Just remember to number them. There was a question to explain again. So what I'm going to do is I'm just going to make this a touch smaller. So it's probably going to be quite small, but just so that you can still see them and just so that I can explain. I assume the question to explain again to Miwa was for question B. So I'm just going to do it on the side here, just away from all the scribbles. We've got 2x cubed y squared all to the power 0. So when I distribute the 0 in, I get 2 to the power 1 times 0, x to the power 3 times 0, and y to the power 2 times 0. Now, all of those, anything times 0 is still 0. So I've got 2 to the power 0, x to the power 0, y to the power 0. And we know that according to our definition, a value to the power of 0 is 1, which means that 2 to the power of 0 is equal to 1, x to the power of 0 is equal to 1, and y to the power of 0, whoopsie, is equal to 1. And so what I actually have here is 1 times 1 times 1. And that's just 1. And so my final answer there remains a positive 1. Okay, so Tamiwa, sorry, I saw your message now. I'm glad that helped. Right, so let me make this a touch bigger for you guys. Oh gosh, got excessive. Right, you're trying those. Remember, if you're putting answers in the chat, just remember to number them so that we know which is which, like Emmanuel's done there. I'm seeing hands, which is awesome. Remember, there's lots of us in the class, guys, so I want to try to give everyone a chance to answer who raises hands. Nice, guys. Well done. And again, remember those zero exponents. Think about which values they actually apply to and which they don't. Okay, Will, what is confusing you? I'm gonna unmute you. Tell me what is confusing you, and let me try help. Okay, unfortunately, I can't explain everything. So tell me, is it the distribution that's confusing you? Is it y it's to the power, or y x to the power 0 is 1? All right, guys, I'm seeing lots of hands. It's really, really nice. I'm seeing lots of answers coming through as well. Okay, the distribution part. Cool. So let's have a look at these examples, and hopefully as we start to do more, it'll make more sense. But otherwise, like Nelisa says, the distribution law was done earlier. So the video will be on Watobe's website for you to go and watch. Alrighty. So Emmanuel, help me with question C.
Okay, ma'am. Ma'am, so I said 3c squared times 3, which gave me 3c to the power of 6. And then I said d to the power of 0 times 3 gave me d to the power of 0, giving me an
So
answer
before we
of,
carry on, what about this exponent of 1 at the 3?
oh, ma'am, it would have been 3, ma'am. So it would have
Okay,
been
perfect.
3 cubed and c to the power of 6.
Perfect.
Yes, ma'am.
D to the power of 0. Awesome.
Yeah.
Okay, now what?
It's gonna be equals to 3 cubed and c to the power of 6, ma'am, because d equals 1.
Perfect, exactly. So guys, remember that d to the power of 0, that gives us 1. And so all we actually have is 3 cubed c to the power of 6. Personally, I like to write the numbers out. So 3 cubed, I would write as 27 c to the power of 6. But 3 cubed is absolutely fine. It means the same thing. It's just written in a different format.
Yes, ma'am.
So whichever one. I personally prefer the number, but it really doesn't matter. Okay, just quickly, Havana, we're not timesing the base of 3 with the exponent. We are timesing the exponent with the exponent. So we're timesing, if I write my multiplication step, 3 to the power 1 times 3, and then c to the power 2 times 3, and d to the power 0 times 3. It's always multiplication of exponent with exponent. All right. Little marks in terms of something like this. Two to 3 marks. If we're not feeling so generous, 2 marks just for the 27 and the 36. There might be an extra mark for not having a d variable anywhere. Not have d, or not having the d variable anywhere. So if you think about it, in a 50-mark test, 2 marks is worth 4%, 3 marks is worth 6%. So it might not seem like a lot, but it all adds up. Right. Oh, God, sorry. Hang on. Just sort my mouth out. Right. If we go to question D, Timolo, do you want to help me with D here?
Hi, ma'am.
Hi.
Ma'am, so I'm not really sure, but then I'd really like to try.
Okay, I'm ready. This is what I like to hear.
Okay, so ma'am, as we know, minus 3 to the power of 0 is gonna give us -1. Yeah.
Excellent. Okay, so I'm just going to skip a step here. We get -1 as our answer, and I 100% agree with you. The reason why we get -1 for everyone who might be a little bit confused, remember that this negative right in front of the bracket, there's actually a ghost 1 there. So what this is saying is -1 times 3x to the power 0. And so again, we can do our distribution into the bracket to the exponent. So we would have -1 times 3 to the power 1 times 0, x to the power 1 times 0. And then once again, we know that anything to the power of 0 is 1. So we've got -1 times 3 to the power of 0, x to the power 0. So what we actually have is -1 times 1 times 1. And so all of those multiplications end up with a -1. All right. Let me just make sure I'm getting everyone's questions. Tato, sorry, I know you missed me. You can leave it as 3 cubes, c to the power 6. Absolutely fine. I preferred writing out the number, but that's my personal preference. Just 3 cubes is absolutely fine. Oratile, I don't really know what you mean by don't we add the x? The x is in the bracket, so it's been affected by the power of 0, which means it has to have 0 distributed to it, which means it will end up being 1. I hope that makes sense. If not, please do tell me. Guys, I will come back for you to get screenshots of everything, so please don't stress. Okay, no, I'm sorry, I just butchered your name. Let me try this again. Oh, but then you left me. You asked me if you could do E, and then you left me. All right. Simonello, do you want to help me with E?
Yes, ma'am. Ma'am,
Okay.
I say, ma'am, 2 times 0, ma'am, 2 to the power 0, ma'am, is still 0, isn't it? Which is also x, which is 1 times 0 is still 0, which will still give you 0 for everything. Then say -3 squared, and x 1 times 2 gave me 9x squared.
Perfect. Okay, so if we look at the distribution again, we're distributing the 0 to the exponent. So we've got 2 to the power 0, x to the power 0. And then the distribution of the squared in the second bracket is exactly what Simonello just told us. It's -3 squared, but guys, really importantly, that negative is inside the bracket. So we need to remember to keep it inside the bracket. And so it's distributing to both exponents again. So x squared as well. 2 to the power of 0 is 1. X to the power of 0 is 1. 3 or -3 squared is +9. And x squared is x squared. Now 1 times 1 times 9x squared doesn't change anything. So we have 9x squared as our final simplified answer. Right, so what was really important in this one was the fact that I was going to say words, now all my words have disappeared from my head, is the fact that we had 2 different types of brackets. We had a bracket that was to the power of 0, but we also had a bracket that was to the power of a non-zero exponent, which means that I should have some value somewhere, and I just need to be careful with my exponents. Okay, there's a lot of questions. Ratio, guys, is coming up. I can't remember exactly when, but it's coming up. It's not what we're currently doing now, so let's focus on our exponents. And there was a question about I don't understand C. I'll go back to C now in a second. Let's just finish off F, and then I'll quickly go back to C. All right. So many hands, which is awesome. So Eddie, do you want to try F for me? And someone's
Ma'am, I had a question.
Who's talking to me right now?
Ma'am, it's Papedi, ma'am.
Oh, sorry, I'm just losing my mind. Yes, okay. What does
I
yours make
had a
sense?
question because my answer is different from question E.
Okay.
My answer is a negative as negative as negative. It's 1 minus 9x squared.
Okay, so just remember the minus sign is inside the bracket. So technically speaking, if we look at this bracket squared, what this is actually saying to us is that we've got negative 3x times negative 3x. And that's then being multiplied by the 1 in front from that 2 to x to the power of 0. Now, negative times a negative is a positive. 3 times 3 is 9. X times x is x squared. So you have 1 times positive 9x squared. I hope that explains it. That negative is inside the bracket. So that negative essentially is going to be, I don't want to say cancelled, but we're going to deal with it at the same time that we square that bracket. If the negative was outside the bracket, so if it said negative and then open bracket 3x squared, then the negative will stay there and then you'll have the 9x squared. But because it's inside the bracket, it cancels out because the negative times the negative is a positive. Right, I'm hoping that makes sense. If we move on over to F, what is daisies? Okay, Emmanuel, help me with F. Or do you have a question?
I have a question, but I can also answer if, ma'am.
Okay, do your question first.
Hey, ma'am. So I think and what I did is I said negative 3 brackets x to the power of 0 and then y to the power of 0 close bracket, and then I said negative 3 brackets 1 plus 1 close brackets.
Times 1.
Oh,
Remember,
1
it's
times 1.
multiplication.
Oh,
Yeah.
yes, ma'am. And then I said negative 3 close brackets 1 sorry, negative 3 brackets 1 close brackets, and then it gave me an answer of negative 3.
Perfect. Okay, so guys, x to the power of 0, y to the power of 0, they both have a value of 1. And so negative 3 times 1 is exactly negative 3. Well done, Voyo. I'm very proud of you. That's amazing. If you guys want, again, if you know, sorry. If you are comfortable with knowing that the brackets to the power of 0, so this whole thing has that value of 1, you are obviously welcome to go straight to the answer of negative 3. As you start to get more comfortable with exponents, you will slowly but surely be able to just skip some steps. But for now, rather write out your steps, rather make sure that you are doing everything correctly, you're dealing with the distribution, etc., before starting to just skip out steps unnecessarily. Right, hope I see your hand. You have a question?
Hi, ma'am.
Hi.
I have a question. So,
Yes.
do the brackets in the sum stand for a silent one?
What do you mean? So like inside the brackets?
Outside the brackets, ma'am.
So yeah, technically anytime you have a bracket with something in it, there is technically a 1 outside. However, in this case, there is that negative 3 in front of the bracket. So technically our coefficient to the bracket here is negative 3. You could think of it as negative 3 times 1 and then the bracket. So the 1 is still there, but the 1 in front of the bracket really only applies when there's nothing else in front of the bracket. Then we know that there's a 1 there.
Okay, ma'am.
That makes
Thank
sense.
you.
Okay, good. Lutando?
Ma'am, how did we subtract the square roots and the 3 in top of the y?
Sorry, can you say that again for me?
How did we subtract the square roots and the 3 in top of the y and had the 0 on top?
Okay, hang on. Where are you getting the square root?
Ma'am, by the brackets, the y square roots to 2 and the x to 3.
I'm confused. I'm gonna be honest. There's no square roots in my example.
Ma'am, may you please re-explain the whole method for me? The whole sum.
Question F.
Yes, please.
Okay, so guys, let's do F again. Let me take this all off. So the -3 is outside the bracket, so that's our coefficient to the bracket. So we just leave it there for now. We'll come back to it in a second. What we want to do is we want to distribute the 0 to the exponents. So we've got x to the power 2 times 0, y to the power 2 times 0. Now we know that anything to the power of 0, anything times 0 is 0. So we've got x to the power of 0, y to the power of 0. And what we then need to remember is that anything to the power of 0 is 1. So that x to the power of 0 is 1. The y to the power of 0 is 1. And remember, between variables, so x, y, you're actually saying x times y. So this is 1 times 1. You still have the -3 in front of the bracket. And so what you actually need to do here is say -3 times 1 times 1. And so what you have is -3 is your final answer. All right, so I hope that makes a bit more sense. Hope, question? Nope, okay. So what I'm gonna do now is just make this a little bit smaller so that you can see all of them so that you can screenshot. There was a question about not understanding C. I'm hoping it does make slightly more sense now that we have gone through all of the examples, but just in case. In C, we distributed this outside exponent of 3 to all of the exponents inside my bracket. So that's what I'm doing over here. I'm multiplying all of the exponents by 3. And then I simplify. So 3 to the power 1 times 3 is 3 cubed. C to the power 2 times 3 is c to the power 6. But here for D, 0 times 3 is still 0. And so that gave us a value of 1, which means that essentially the D just fell away and we were left with 27c to the power 6. Or you can leave it as 3 cubed c to the power 6. It doesn't really matter which one you want to do. Both is absolutely fine. Right, so I'm just waiting here in case anyone wants to take a screenshot. Well, I'm hoping we all want to take a screenshot because it's got all the answers on it. Then we are a bit over our time for a brain break, but we will still take a brain break because you guys have done really nicely here. Okay, screenshots, 3, 2, 1. Right, brain break. Here it is. So I want you to, well, I'm going to read the question, but just make sure you're going carefully through this. So it says the picture shows identical right angle triangles. So they're all exactly the same. The triangles next to one another are connected along their edges. So they all fit perfectly flat against each other. The question is asking, what is the angle at the tips that are marked with the dots? So what is the size of the angle? And these are all of these angles up here at the top. So take a second, have a think about what you think the size of those angles are, how you think you can go and calculate them, and then we'll have a look. You can put your answers in the chat. You're also welcome to raise your hand. Glad we're all enjoying the joke today. So have a think about those triangles and think about what a right angle triangle means. Oh, I like that one. Ortile, good math joke. Sibonelo, so the problem that you're trying to solve here is what is the size of all of the angles I've highlighted in green there. So you know that these are all right angle triangles, that you know that these angles here are all 90 degrees. So what you're trying to do is you're trying to work out these angles at the top here. And you know that all of the triangles are joined at the central point in the middle here. And that's going to be quite helpful for you to try and figure out what these angles in the center are. I'm sort of giving it away here, but have a think. Menetle, do you want to try? Okay, I'm ready.
So is it 45 degrees?
Okay, explain your working out to me. What did you do?
I said 90 minus 45 because on the right hand side it's 90 and I guess that on the left hand side was 45.
Okay, so guys, let's try not guess. You're very close with 45, but it's not quite 45. Amatli, do you want to try?
Hello, ma'am.
Hi.
Ma'am, so I don't know if it's right, but on one side the angle equals to 90 degrees, and we know that each triangle has to equal to 180 degrees. So 180 minus 90 will give us 90, which will, I think that will be the answer for the missing variable.
Okay, so just be careful. We don't want another 90-degree angle there, because otherwise we have a situation that looks like that, and that's not a triangle anymore. But again, really close. So what we need to sort of have a look at here is what Nelisa said in the chat. Look at the fact that you've got all of these angles forming a circle in the middle here. That's going to help us. Mzile, do you want to try?
Afternoon.
Hello.
I think, if I'm thinking correctly, we have to divide by all those 9 triangles, which I got. Let me see. I got 20 for each.
Okay, what are you dividing though? What's the number that you divide?
I'm dividing 180 divided by 9.
Yes, remember 180 is the angles on a straight line. What is the size of an angle around a point? So what's the size of the angles around a circle?
It's 360.
360, good. So what we want to do is we want to say 360 divided by those 9 angles, like you said. So what is the size of the angle?
So,
oh, okay. I'm seeing some awesome answers on the chat. So it's 40. Now, guys, we can do that because it told us that they're identical triangles. So all of these angles here around the middle are 40 degrees. I'm not putting them all in. And so now if we go back up to one of our triangles, we've got 2 of the 3 angles. If we look in our triangle, I know I've got a 90 degrees there in the corner. I've got the 40 degrees at the center. And so if I now want to work out what my missing angle is, I can use sum of angles in a triangle. So 180 minus 90 minus 40. And that tells me that this angle here in the corner, right at the top, is 50 degrees. Alrighty, so I'm hoping that makes sense. This was quite a tricky one. Like it was a nice challenge. And it's important to read the questions carefully, because that identical over there meant that we knew that all 9 of those central angles were exactly the same. Now, guys, remember the brain break is not part of like the actual maths. It's just something nice to take a little break from what we're doing. So if you don't get it right, that's cool. It's just something to have a try of. All right, it's not something to stress about. Amake, your hands up. Right, so guys, we've got 10 minutes. Let's try, whoopsie. Let's try one more combined one and see how we manage with our combined questions. So this is now where you might need to use all of your laws of exponents in order to simplify this fraction. Bonello, question?
Ma'am, I just wanted to answer A.
Oh, already? Okay, let's give everyone a chance and then we'll have a look.
Should I try, ma'am, or should I just leave it for now?
Let's just hang on for a little bit. I'm going to give everyone a chance to give it a try and then we'll have a look. Okay.
Okay.
Cool. You can just ignore me if I'm not pushing things. Okay. Remember, the joke is the joke. You don't have to feel the joke. That's absolutely fine. Today is quiz day, Avril. So in a minute or so, you're going to get the quiz link. So we will send it to you. Don't stress. It's all coming up. Let's try this question A over here and then mark it so that we can do the quiz. Remember where your zero exponents are, and remember your different laws of exponents, because like I say, we're now combining everything. So we're going to have to use all of our laws in a question, and these are the types of questions we're going to ask you, combining all of your exponent laws into one question. Theo, very close. Double check that y exponent. I'm going to give everyone another minute or so. I'm liking some of the answers. I just want you to double check your exponents for y there. The x is looking good, but double check the exponent for y. Nice. Manentle, are you wanting to try?
Yes, ma'am.
Okay, I'm ready.
So we say we distribute the 2 to the x and the y, and then it's x to the power of 2, and then y to the power of 4, and then we times it by x to the power of 3 and y to the power of 3, because we distributed the 3 to the x and y.
Excellent.
And then, ma'am, that would be x to the power of 5 and y to the power of 7.
Okay. Oh, whoopsie, sorry. Oh, it's a bit crazy there. Sorry. So if we were to simplify that, x to the power 5, y to the power 7. Okay, I'm just doing that in my next step. What about in the denominator? Or rather, what about this x to the power 0? What happens to that? Okay, so guys, remember, and this is actually what I wanted to say now. Anytime you see that power to 0, like I said, something in your head should be saying, I probably have a value of 1. So what we can do is we can take both of these bases that are to the power of 0 and we can automatically say that they're 1, which means that we can not ignore them, but we can essentially drop them because 1 isn't going to change anything. Timesing this whole thing by 1 isn't going to affect anything. It doesn't change my values. So it means that I can just essentially drop those 2 to the power of zeros. And so in my denominator, I've got x squared y. Now, as Melinda said, if you multiply everything in your numerators, you multiply your x's together by applying your first law of exponents and adding the exponents, you get x to the power 5. And the same thing with y, you get y to the power 7, all over x squared y. Now we don't stop there. We need to simplify as far as possible. So this is now where we need to apply our second law of exponents, and we need to subtract the exponents because we are dividing. So x to the power 5 minus 2 and y to the power 7 minus 1, because that y in my denominator has an exponent of 1. And so I've got x cubed y to the power 6 as my final answer once I've simplified everything. So really, really important. You should never have the same variable in your numerator and denominator. If you do, it means you need to simplify further. So I knew I wasn't done at this step over here because I still had an x at the top and an x at the bottom. I needed to go further with my simplification. For you, do you have a question?
Ma'am, yes, I do have a question. First of all, can you hear me?
Yes.
Okay. Ma'am, I wanted to find out, how did you get the 5 with the variable, the x, the first one? It's in the numerator, the denominator. I mean the numerator.
Right. So
sorry, I always get them confused.
It's all right. I completely understand. So I got the 5 from the
Yes,
2
ma'am.
exponents over here.
Oh, so you added them.
Yes, exactly. My first law of exponents says that when I am multiplying the same base in exponents, in order to simplify that, I add the exponents. And so I just go and add the 2 and the 3 to get 5.
Oh, okay. Now I understand.
Okay.
Thank you, ma'am.
Good. Bokang, question? Oops, there we go.
Hi, ma'am.
Hi.
Ma'am, may you please explain how you got on the denominator, how you got x squared?
So it came from this bracket here. So that whole bracket was my denominator, because remember this bracket over here that I've highlighted in blue would be x to the power y 0, x to the power 0, y to the power 0, which is actually just 1. So it falls away.
Oh, thank you, ma'am.
Pleasure. Alrighty, guys. So quick recap. We distributed our exponents, which is where we got these new exponents in our numerator from. We dealt with the 0 exponents. Those were both equal to 1, and so they could fall away. And then I could apply my exponent laws to multiply the numerator and to simplify my fraction. Right, and these are the sorts of combination questions that we'll ask. And as Annalisa says, we apply all of our laws to these sorts of questions. Alrighty, guys, so I'll leave it there in case you want to take a screenshot. You're going to see the quiz link come up now in the chat.